In this lesson, you're going to learn how to find the greatest common factor of two numbers. This is one of the basic skills in fractions that you're going to be using into reducing fractions later on. To find the greatest common factor, you have to be able to first write the factors of numbers. I'm going to do this on this page here, but I recommend that you get a separate sheet of paper because you're going to need some more room to solve these problems. So let's look at problem number 1. It asks for what is the greatest common factor between the numbers 20 and 48. Well, I'm going to write the number 20 down and the number 48. Then I'm going to look at just the number 20 and write down all the factor pairs of 20. These are all the numbers that multiply together to equal 20. It does involve that you know your multiplication and division facts pretty well. But you can start off with the number 1, because 1 times anything always equals itself. So 1 and 20 is a factor pair of 20, because 1 times 20 equals 20. Now I'm going to write these as pairs, so I'm not going to write the times symbol in between each one. Another way to think of this is 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 3, well, 3 doesn't go into 20. Now, you're going to be counting all the way down. Let me go ahead and finish this one up here first, and I'll explain. 20 divided by 4 is 5. And when you write all your factor pairs, what you're doing is trying to find the numbers in between that multiply, so that 1 and 20 is the biggest factor pair that you can get. Now the next pair, the 2 and the 10, is in between 1 and 20. The pair after that, 4 and 5, is in between 2 and 10. There are no numbers between 4 and 5. So that's how I know I'm done. I've written all my factor pairs. There's other instructors that will teach you to write factors like this. They'll write 1 and 20, 2 and 10, 4 and 5, so that you can see, hey, I'm getting to the center, I'm almost done. Now that's fine, but what this lesson is to lead you to in the future is reducing fractions. So I really want you to use this method here where you write them side by side, and I'm going to show you why in the next lesson of reducing fractions. It's going to make a huge difference. Oops, that 5 disappeared on me. There we go. Alright, so let's write all the factor pairs of 48. Well, we start with 1 and 48. 2 and, I know that 2 goes in 48 because 48 is even. This all has to do with these divisibility rules. Let me pull these up and show you some divisibility rules, and I think this will really help you when you're trying to come up with your factor pairs if you don't know your facts that well. Okay, what I have up for you is the rules of divisibility, and this is on your Blackboard page. The rules of divisibility will help you find what numbers divide evenly into, especially larger numbers. Now, you should be able to really write out all your facts of 48 just by going down if you really know your division skills well. But let's use this for a minute here. So here's our rules of divisibility. Any number can be divided by 2 without any remainder if the number is even. Well, look at the number 48. Is that even? Well, I guess we first need to remind ourselves what's the difference between even and odd. Even is the cheerleader chant of 2, 4, 6, 8. Who do we appreciate? Even numbers. Don't forget 0 though. 0, 2, 4, 6, and 8 are even numbers. The odd numbers then are 1, 3, 5, 7, and 9. These are odd. Right. So any number that ends in any of those digits right there, here's our last digit right there, the 8, then that means that this number 48 is divisible by 2. So let's write 2 down. 48 divided by 2 is 24. You can check with the calculator if you don't believe me, but you should be able to do that fact in your head. As you get better with that fast math, you'll be able to pop those numbers in your head. Alright, now 3. Can 3 go into 48? Well, here's the rule of 3. If the sum of the digits can be divided by 3, then the big number can be divided by 3. What I mean by that, the number 48 has a 4 and an 8 in it. If we were to add 4 plus 8, you would get 12. Can you divide 12 by 3? Sure, because we know that 3 times 4 is 12. So that means the number 48 can be divided by 3 without any remainders. Let me see if I can do that somewhere over here. 48 divided by 3. 4 goes in 1 time, so there's 3. Remainder 1, bring down the 8. 3 goes in 6 times. There we go. So 16. 3 times 16. See, it takes a while to do long division. By knowing these rules, you'll know which ones to actually take the time to do the division for. If those two digits didn't add up to a number that can be divisible by 3, then we would have wasted our time. You would have had a remainder. Alright. The rule of 4 says if the last two digits of the number is divisible by 4, then the big number is divided by 4. Now, we're looking at just only a 2-digit number. Yes, this goes in 4 times. 48 can be divided by 4. I can kind of see that because I see the 4, which can be divided by 1, and the 8 can be divided by 4 2 times. So 12. The next rule says if the number ends with a 0 or 5, then it can be divisible by 5. Well, the number 48 ends in 8. That's not a 0 or a 5, so we know 8 won't work. Look at the next rule. For the rule of 6, a number can be divided by 6 if it's divisible by both 2 and by 3. Well, look, we were able to divide it by 2 and by 3. That means we know for sure that this number can be divided by 6. 48 divided by 6 is 8, isn't it? Yeah. Alright. The rule of 9, now here's where I'm going to stop for a second. Notice we have 6 and 8. What numbers are between 6 and 8? Just the number 7. I don't have a rule here for the number 7, and I don't know of any rule for the number 7, so I just have to ask myself, can I take 48 divided by 7? No, I don't know any number that goes by 7 times. So actually I'm done with all my factor pairs of 48. But let me go ahead and finish telling you about these other rules of divisibility. Number 9 is just like number 3. It says a number can be divided by 9 if the sum of the digits can be divided by 9. So if we were to add up those digits again, 48 equals 12, and ask yourself, can 12 be divided by 9? No, I don't know of anything that, 9 times nothing equals 12. So it can't be divided by 9. And the rule of 10 says if the number ends with a 0, you can divide it by 10. Again, our number ends in 8, so it can't be divided by 10. So these 7 rules, 2, 3, 4, are the rules that you're going to be using every time you are trying to find your greatest common factor, which eventually is what you're going to have to do to reduce fractions later. Just a quick comparison of these rules. Some of these rules involve looking at the last digits of numbers. The rule of 2, 4, 5, and 10 all deal with looking at the last digits. This will help you remember these rules. The rule of 3 and 9 are the rules where you have to add up the digits and then ask yourself, can you divide by it? And then finally, the rule of 6 involves both. You not only have to have an even number, but the digits also have to be divisible by 3 to be divided by 6. So you can imagine there's not a lot, compared to all the other numbers out there. 6 is probably the least amount of numbers you can divide by, oddly enough, other than 7. And I don't know, like I said, a rule for 7, but there aren't that many numbers out there compared to the other digits that you can divide by 7. So use these rules when you're trying to find your greatest common factors or to write all your factor pairs. Okay, let's go back to the worksheet. I had to rewrite these, and I think I made a mistake earlier when I was showing you this. This one looks different than, I remember when I was doing this, I'm like, that looked weird. Why do I have 14 and 12? Those are too close. So I had made a mistake a little bit ago. That is supposed to be a 24 if you're trying to think, I'm going to get extra credit. I already found one of Stacy's mistakes. Yeah, I found it for you. So yeah, that should be a 24. Okay, so I wrote all the factor pairs of the 20 and the 48. So how do I find the greatest common factor? Well, first of all, let's talk about what a common factor is. A common factor means it's a factor in both numbers. Let's see if we can find any common factors here. Well, 1's a common factor. It's in both sets. So's 2. So's 4. Are there any others? I see 12, 5. I don't see others. So 1, 2, and 4 are all what are called common factors. They're in both sets. It's what they have in common. 20 and 48 both have 1, 2, and 4 in common. But the greatest common factor means the largest number they have in common. In this case, it's 4. So the greatest common factor between 20 and 48 is 4. I'm going to do another one for you, and then you need to do the rest for your practice. I'll have the answers for you posted so you can check your work. I'm going to do problem number 2, and then I'm going to skip down and do one of the bigger numbers for you. And then you can do the rest. Alright, for problem 2, you're trying to find the greatest common factor of the number 24 and the number 60. So let's do it again. Let's write all our factor pairs of 24. 1 and 24. 2, and I know it can be divisible by 2 because 24 is an even number, is 12. Can it be divisible by 3? Let me add up my digits. 2 plus 4 is 6. Oh yeah, 6 can be divided by 3. Now we're not taking 6 and dividing by 3. We're taking 24 and dividing by 3. 24 divided by 3 is 8. Can it be divisible by 4? Yeah. 24 divided by 4 is 6. And the only number between 4 and 6 is 5, and 5 can't go into 24 because it doesn't end in a 0 or a 5. All the factor pairs of 60, 1 and 60. 2, yep, that's an even number, so it can go in 30 times. Add up my digits again. 6 plus 0 is 6, and 6 can be divisible by 3, so yep. 60 divided by 3 is 20. Now, I don't think 4 can go into 60. Maybe it can. Let me double check. It is 2 digits, but that's still a little big for me. So 1, 4. Oh, yep, it can. 15 times. Five can go into 60 because it ends in a 0. So 60 divided by 5 is 12 times. And then 6 can go into 60 because it can go into 2 and 3 work, so that means 6 has to work. 6 and 10. 7 doesn't work. 8, I don't think it would work. Let me check. Yeah, no, it doesn't. And 9 does not go into it because 6 can't be divided by 9, so 9 can't do it. And then I'm back to 10 again. And we already have 10 on our list, so we're done. These have lots of factor pairs. Let's see, we have lots of common factors. 1, 2, 3, 4. 6 is common. It doesn't matter which side it's on, they're still common. 12's common. And I believe that's it. So our biggest number then is 12. So that's our greatest common factor is 12. Alright, I'll do one more for you, but I'm going to skip down to help you with it. Alright, let's look at number 9. We have 3 numbers that we have to find the greatest common factor between all 3 numbers. So you're going to follow the exact same procedure. Let's write all the factor pairs of 40, all the factor pairs of 85, and all the factor pairs of 105. So 40, we have 1 and 40, 2 and 20. That only equals 4, so 3 doesn't go into it. 4 does, 4 and 10. 5 does because it ends in 0, so 5 and 8. 6 can't go into it because it only went into 2, but it didn't go into 3, so 6 won't work, and 7 doesn't either, and we're back to 8 again. There's no other numbers between 5 and 8, so that's it. 85, we got 1 and 85. 2 can't go into it because 85 is not an even number. 8 plus 5 equals 13, so 3 doesn't go into it. I don't think 4 goes into it. 5 does because it ends in a 5. I'm going to have to do that over here. 85 divided by 5. 5 goes into 8 one time. Remainder 3, bring down the 5. 35 is 7. So 17 times. 6, I do not believe goes into 85. 7, I don't know. Let me take a minute and see if I can find any others for you. I was about ready to try 6, but I know 6 doesn't work. That's why these divisibility rules will really help you. 2 didn't go into it, and neither did 3, so 6 cannot go into 85. 7, I told you I don't have a rule for, so we can try 7. 85 divided by 7. Nope, doesn't go into 7 times. I don't think 8, 8 doesn't go into it. 9 doesn't go into it, and that's 10, 11, 12. But yeah, I think we're done there. So there wasn't that many, even though 85 is kind of a big number. 105, you have 1 and 105. 2 can't go into it. 1 plus 0 plus 5 is 6, so that means 3 can go into it. I'm going to have to do it over here. 105 divided by 3. It's 3 times, get 9. Bring down the 1 is 5, so 35 times. 4 I know can't go into it because you only look at the last 2 digits for 4, and 4 can't go into 5. 6 can't go into it because it's not an even number. You had been 2 and 3. 7, I don't know about. I'd have to check. Erases some work here, so I will. There we go. I need to erase a little bit so I had a place to work. So 105 divided by 7. Oh, it does. 15 times. Eight. I believe was 8 on that list there. I think 8 has the exact same rule as 4. And you look at the last 2 digits. No, 8 can't go into it. 9. No, 9 can't go into 6. So we know it can't there. And then 10, it doesn't end in 0. So let's look for our common factors. We have common factors of 1. And that's really it. No, there's got to be another one. Oh, we skipped one. Look at 105. It ends in 5, so 5 should have been able to go into it. I don't know where I missed that one. So 105 divided by 5. 2 is 10. Bring down the 5 is 1 is 21. So 5 is a common factor in all 3 numbers. So the greatest common factor on number 9 is actually 5. Okay, so that's what you do when you have 3 numbers. Go ahead and try some more of these as much as you can on this page, and then self-check and correct.